For many people around the world, menstruation is just part of everyday life. Many of us in North America take for granted the single-use products like sanitary pads that can make menstruation more comfortable, and it can be hard to imagine life without the disposable products we're used to. But there are many people who cannot afford these products, which creates social, economic, and educational barriers for those who have to go without. So are we really getting the best product for ourselves and for the planet? And how can we make these pads more affordable for the billions of people who don't have access to proper menstrual hygiene? The modern sanitary pad relies heavily on plastic and petroleum products to make them ultralight and absorbent. In 2018 alone, people in the US bought nearly 6 billion pads and tampons. Most of these products pile up in the landfill or environment where they take hundreds of years to degrade.
But the good news is that menstrual pads can be made sustainably with nanocellulose.
Nano what, Yellows?
Well, nanocellulose is just a tiny cellulose structure. So tiny, we can only see it with a microscope. It comes in 3 forms: cellulose nanocrystals, cellulose nanofibers, and bacterial nanocellulose. The one we want is cellulose nanofiber, which is made of highly concentrated small fibers that have a high aspect ratio, or length to width ratio. The typical nanofiber is 1,000 nanometers long and 4 nanometers thick. There are so many great things about nanocellulose. For one, it is a high strength to weight ratio. It is also non-toxic, gas impermeable, liquid resistant, and can form super thin walls. But our favorite thing about nanocellulose is its high tensile strength and its ability to form highly absorbent materials, because this makes it perfect for better menstrual pads.
How are sanitary products currently made? Right now, pads use superabsorbent polymer gels, SAPs, injected into the cellulose structure to increase absorbency and decrease pad thickness. The problem with this is SAPs don't break down in the environment and increase the price of pad both environmentally and economically. What makes nanocellulose a better option? When sources undesirable byproducts of paper making, such as excess fines, this can reduce costs. The chemicals used in the pulping and extraction process are highly recyclable, and very little wastewater is produced. Nanocellulose is inherently biodegradable and bioabsorbable, making it the clear environmental choice.
First, wood chips are added to a homogenizer with water. The pressure and temperature is then increased to soften the lignin and amorphous regions of the cellulose. This will make it easier to release the fibers. The mixture is then hydrolyzed by adding nitric acid to the pulp, which breaks down the cellulose and lignin and releases the wood fibers. The solution is then diluted to end the chemical reaction. A centrifuge separates the solution into the different types of nanocellulose. The solution is then dried to a powder. For menstrual products, the cellulose nanofibers are freeze-dried and may undergo an electrospinning process.
Among the derivatives of cellulose, cellulose acetate is a biocompatible biopolymer which is easily available and has low cost. It shows good hydrolytic stability and can be recycled in the environment by biodegradation. Furthermore, cellulose acetate can be electrospun into fibers. The basic setup of electrospinning consists of a syringe pump, voltage source, and a collector. The electrospinning process uses an electric field as a driving force to draw fibers from the electrically charged polymer solution out through the needle tip and onto the collector. To get continuous uniform nanofibers and the desired characteristics, there are many parameters which can be changed. These include feed rate, voltage applied, needle tip to collector distance, and the needle tip diameter, as well as the polymer type in solution. The fibers obtained from this process generally possess characteristics such as high surface-to-volume ratio, porosity, and flexibility from a controllable diameter, making them highly tunable for use in a wide range of applications. All of these characteristics happen to make for a highly absorbent and comfortable menstrual pad. In all substances tested except for specifically distilled water, the pure cellulose acetate fibers consistently outperformed commercially available SAP-based products by at least 50% absorption by weight.